Having reviewed antiderivatives of constant functions, let's make things a little more complicated and look at integrands with an x in them. So here I want to find the antiderivatives of 2x with respect to x. Now, recalling our work from derivatives, we know that if we take the derivative of x squared, right, we bring the power down and multiply and subtract 1 from the power. And so in this case, we'll get exactly 2x. But not only does x squared have a derivative equal to 2x, x squared plus any constant will also work. Right? The derivative of x squared plus 1 or x squared minus 5 is still just 2x. So what about the antiderivatives of 4 times x? Well, as we just saw, to get a derivative involving x to the first power, we need to do something with x squared. So let's just think this through. If we take the derivative of x squared, that's going to be 2x, but I want 4x, right? When I multiply, I want to get 4. To figure out the coefficient in front, I'm just going to take 4 and divide it by 2. And 2x squared has the derivative of 4x. Again, we can add any constant onto that and still get a derivative of 4x. So what about antiderivatives of 3x? Well, to get an x in our derivative, we're going to need some term involving x squared. And what sort of coefficient do we want out in front? Well, when we multiply by 2, we need to get a coefficient of 3. So my coefficient here should be 3 divided by 2. And again, add on any constant. So let's just look at one more. What about the antiderivatives of negative 5x with respect to x? Again, we need an x squared so that when we take the derivative, we get an x to the first power. My coefficient here, I need to multiply by 2 to get a negative 5. So my coefficient here is going to have to be negative 5 divided by 2. And again, add on our c. So this is kind of a natural justification for the following thought process. If I want to find the antiderivatives of something like 3x to the fourth, right, I just want to reverse my derivative process. So I want to add 1 to this power, and then take the coefficient and divide by the new power. So the antiderivatives of 3x to the fourth are 3/5 x to the fifth plus c. What do we need to take the derivative of to get an x to the negative fourth? Well, add 1 to the power. We need something involving x to the negative 3. My coefficient out front is going to be negative 2 divided by this new power. So that's going to be a positive 2/3. Right? Again, notice that when we take the derivative of this function, negative 3 times 2/3 gives us the negative 2, and we'll be subtracting 1 from this power to get the negative 4. Antiderivatives of x to the fifth. Well, to get x to the fifth, we need to add 1 to that power, so we need something involving x to the sixth. To get a coefficient of 1, divide 1 by the new power, so our coefficient here is 1/6. So this rule works with any power except for -1. We'll address -1 in the next video. It even works with fractional powers. Suppose we want to find the antiderivatives of x to the 2/3. Well, I need a power that when I subtract 1 I get 2/3. So let's take 2/3 and add 1 to it. So 2/3 plus 3/3, right? Our new power is going to be 5/3. And I'm going to take the coefficient of 1 and divide by 5/3. So this is the same as multiplying 1 by the reciprocal. So my coefficient here is going to be 3/5. And add C. Also works with negative fractional powers. To come up with my new power, I'm going to add 1 to -4/5, and that's going to be 1/5. I want to divide 2 by this new power. 2 divided by 1/5 is the same as multiplying 2 by 5. So my coefficient here should be 10. And again, this checks out. If we check our work, take the derivative of this right side. 1/5 times 10 is 2. 1/5 minus 1 is a -4/5.